The Beijing Olympics, 2008, the main issue in terms of Beijing Olympic that caught the imagination of the world was the smog in Beijing, and it was largely ozone. So here is meant to reflect that the ozone problem in Beijing. And you know, the solution that they came up with was to shut down all the factories surrounding Beijing and then move them out into rural areas and so on and on and on. Well, nevertheless, the effects of ozone, it leads to the formation, helps in the formation of acid rain. Certainly, it's a very important constituent of smog, and it leads to the formation of fine particulate matter, PM fine. It leads to enhanced respiratory diseases, excess amount of ozone if you were to breathe. It leads to premature mortality, depending on the population, the aged and the young, you know. And it certainly has damage to crops and material as shown right here, and I'll show you some additional slides in a minute. And so the consequences of all these effects is that we need to have control programs if we are to have effective air quality in the region that we live in. And inevitably, all this leads to restricted industrial development in the places where we have an air pollution problem. It's primarily for this reason that in eastern North Carolina, where we have intensive agricultural problem, no industry wants to relocate there because they don't want to have to go clean up that place, you know. That has to be dealt by the industry that happens to be there already. So is the case with if we have an ozone problem, the industry is reluctant, which has direct economic consequences. So I'm going to show you next few slides on how crops are damaged and how this study gets done. So here are plants, primarily soybeans, healthy looking soybeans, and we expose them to ozone concentrations in what is called open top chambers. So these are chambers in which we bring in ozone at a known concentration. We expose them for a bunch of hours, and then we look at what's the damage that gets done, and then we compare them with plants that are not exposed to ozone. Here is another experiment, and which is a more sophisticated way of looking at exposure to plants, which is called a FACE experiment, which is a free air ozone experiment, in which there are no walls. Ozone comes out through these pipes, depending on the wind direction, and it blows over the plants. So there are no wall reactions. So these are sophisticated advancements on how exposure studies get done. And here are some studies that we did in what is called a continuously stirred tank reactor, in which we expose plants to ozone and other pollutants. So here are different ways of trying to look at effects on vegetation. For the record, that's how it is done on humans also. You have a chamber which is located at UNC Chapel Hill, and in this chamber we expose human subjects to a variety of different pollutants, and then we see what the impact would be. But we don't nearly take them to very high values. To do that, we rely on human models, which are really rats and cats and whatever else, you know, and we expose them. So here is an open-top chamber experiment in which the soybean plant was exposed, 25 parts per billion, which is not very high value for 12 hours, and you can see the damage on the plant. And the congressional office calculated that the total loss to the US economy was somewhere between $2 and $5 billion 10 years ago. Not today, 10 years ago. They haven't calculated that number now, but that's what it was then. So that's a substantial number to be worried about. And so here is the effect of ozone on yields of crops for different crops, sorghum, field corn, and so on, and ultimately cotton. the decrease in yield going in this direction and increasing ozone concentration. And the ambient ozone value is between about 45 to about 65 parts per billion. And we see that as you increase ozone concentration, the yield for the crop declines. So clearly, these studies have clearly shown us that there is an impact on vegetation associated with elevated levels and ambient levels of ozone. Now the good news, and there is some good news. The US Environmental Protection Agency makes measurements of ozone in a variety of different locations around the country. To be exact, 258 locations. So from 1980 to 2008, over almost a 30-year period, so this is going 1980 to 2008, ozone concentration in ppm, and this dashed line is the standard, 0.075 ppm. If you are above it, bad news. If you're below it, you're doing fine, okay? What do we see? That indeed, the ozone concentration, nation as a whole, is coming down. But it is not down enough so that the problem has gone away. The problem, there are still a variety of regions where the ozone continues to persist above this value. How about North Carolina? And that's what I'll focus on. Ozone is measured at all these blue dots location that you see here in the state of North Carolina. And what do you see? Predominantly in the triangle area, in the triad area, and in this corridor right here. Essentially along I-85 and along I-40. Okay, those are the communities, for the reasons that I shared with you a little while ago, will produce the precursors to ozone formation. So this is where we are at right now in this region. And what do we see? North Carolina 8-hour ozone non-attainment. That is, regions that have monitors that have the yellow dot is non-attainment between 76 parts per billion. 0.075 is 75 parts per billion with a B. And to 84 and beyond 85, that's called a serious non-attainment. And what do we see? Where we are right now, we do have a serious problem as it relates to ozone. Between these measurements were made for 2006 to 2008 because the new standard came into being in 1997, and we are only looking at 3 years at a time. So we have a serious problem here still, but the problem is quite pervasive in the triangle area, the triad area, and in this area. Okay? And so a monitor is then translated into the region that it might affect. And the same monitor then, all these regions shown right here have a ozone-related problem. But there is some good news here too. It's not entirely all that bad. So let's look at the statewide air quality considering ozone. So only for ozone. 1998 to 2008. Up until 2008, the standard was 0.085. From 1997 to 2008, the standard was, ozone standard was 0.08 ppm over 8 hours. The standard was made more stringent. What we see is for the state of North Carolina, the ozone has continued to decrease